Okay folks, this is an update to my Fukushima radiation levels explained. I've added some modifications to the equation, and that's mainly what this is about. Of course, you still have your y plus your p times z minus your 0.5 times y plus your p to the z minus 1, which is your range over your x equals 1, which is your starting point. That summation equation is 1 minus x over z. Now z, once you calculate for z, but you have to calculate z differently, and we've got this example down here, 262,800. That's the number of hours that strontium-90 takes to half-life. It's in hours instead of years. So that would replace z, and it would be that number minus 1. Then of course you'd put z over here as well, but it wouldn't be z minus 1. Then the x goes all the way to z, to the z minus 1 equation, and that replaces x. That's basically how that works. Well, don't really have anything other than that to mention, except for the fact I'm updating the that particular part of it. The half-life has to match the continuous outputs time frame, like if it's in minutes, days, hours, or whatever. The half-life has to match that. So if it's a half-life of, say, 8 days, but your P is in 1 hour, so you get amount per hour of continuous output on an hour, such as those right there, that 73 sieverts or 530 sieverts per hour. If you get that, then you have to put your Z in hours. So if you have, say, in the case of iodine 131, it's 192 hours. So Z would be 192. Z minus 1, which you have to do manually, would be 191, which you would put there when you punch it into the equation in your computer. And then of course you put the 192 for Z there, and then the X automatically calculates if you use a summation, which is what that's called. That's actually, I think, a sigma sign. Well, that's pretty much that. That's what this update was covering, was that update to my equation. Well, you have a good day out here.